So your startup company, well, comes in later. Let me start up with you and you growing up.
Can we do a salam first?
You can do a salam, yes, of course. Go ahead.
Hi, salam.
Salam.
Everybody say salam back. Okay, I would like to start with your background first, as we usually do over here. I would like to start with you, ladies, first. You grew up in Iran. You were born and you grew up in Iran. And you went to Sharif. What was your major over there?
I studied electrical engineering.
And what high school did you go to?
I went to Farzanagan.
Farzanagan. Okay, so were you part of the Olympiad also, or no?
Very early stages.
Very early stages.
Yeah.
And
Didn't
then
make it all the way
after Sharif, you came to the United States?
That's right. Yeah.
And where did you go?
I went to Boston. I went to Northeastern University to do a PhD in electrical engineering.
Uh-huh.
And then, shall I continue? Or
Go ahead.
How do you want to do
I will
this?
stop you sometimes.
I just heard you can be brutal, so I'm just trying to.
I
figure
can
out.
be brutal? Oh, come on.
You gave us 1 minute, and that's all I learned from the person.
Oh, you said I'm no sense said that.
So I came to the U.S. Wanting to continue down the electrical engineering path, and then I completely randomly got introduced to this amazing professor at Harvard. His name is Ali Khadim Hosseini.
Mm-hmm.
If you haven't heard of him, which I'm sure a lot of you have, he's a great asset of our community, I believe. We completely randomly met at an MIT party, and then I got interested in learning more about bioengineering and life sciences. So I went to his lab and I switched over. So I used to spend until 9-10 p.m. and then weekends in the lab trying to do really exciting work in what was called tissue engineering.
So the professor made you switch from pure engineering or the world of atoms and electrons into something live,
sciences.
essentially.
That's right. And then after that experience, I decided to switch majors. I applied. I got then my PhD from UCLA in biomedical engineering. After that, I worked for about a year in industry and then went back, wanted to become a professor, and then the rest maybe we'll
So
cover
first
later.
it was your academia love that you wanted to get into.
Yes.
And someone changed that, right? Or something or someone changed that. I guess for that story we're going to go to...
I don't think.
Well, maybe I can...
I'll take that blame.
No,
I'll take
why
a
don't you
step
start
back.
with your
Yeah.
background? You were born in Iran.
Yeah, born and raised in Iran. I also went to Sharif.
But you were both in Sharif within several years, but you didn't know each other.
We didn't know each other all the way until we got here in San Francisco, because we also spent some time in Los Angeles. I went to USC, she went to UCLA, but
you did not meet over
we
there.
were very focused on
So you were
studying.
bound, you were shadowing each other over the years. You were bound to meet. And when did you actually meet and where?
Oh, where did we meet? We met at San Francisco City Hall, which a few days later we actually got married there too, for a Nowruz party.
Mm-hmm.
Yeah, but anyway, so it's back to that Sharif computer engineering. Then I came to USC for PhD in computer science. Then I did a little tour of Europe for internship at Amsterdam, and then postdoc at Microsoft Research Cambridge. And then I came back to the US for work. First, I did a startup on my own. I crashed. Then went to Google, worked there for a few years, and then I started the second one.
Before starting the second company, you got married.
That's true.
And a year after that, you started your company, which is your baby in a sense, right? So who's the boss over there? Wait a minute. Yeah, she is. She is
No
the
question.
CEO and you're
No
the
question.
technology.
That's the right
Whose
answer.
idea was it? That's the right answer. Whose idea was it?
Well, you say, boss.
It was really a really interesting entanglement of work and us getting to know each other. And I think one of the first things that got us both attracted to one another was the passion that we had for what we do. And I think throughout that conversation, I was trying to do something very challenging. I was a postdoc at Stanford at the time when he was at Google. I was trying to do something challenging on my side. I shared that with him. He was thinking a lot in AI and deep learning world because that was where he was launching a product. And kind of the ideas came together throughout a lot of conversations. Can't really tell whose idea it was first. We started talking a lot about how we can apply some of what the tech world has been kind of adopting at that point, and then what we can use it for in the problems that we were trying to solve. We also have a third co-founder who is my postdoc advisor, Dr. Ewan Ashley, who is a great figure in as a clinician and a statistician and a Stanford professor. We've been very lucky to have him on our side as well. So the three of us would get together and dream a little bit, and then the whole project Deepcell started when we filed a patent at the Office of Technology Licensing at Stanford, and we got.
About what year? This is 2018.
This is 2016.
16.
This is 2016.
Preceded 2 years by 2 years doing the company actually.
Yeah. Yes. So yes, we got our patent filed, and then throughout conversations with the OTL, we got funding. We had an hour-long conversation, by the end of which the director asked us, how much do you need to build a prototype? We said $250K, and they gave us $250K.
Right there?
Right there.
Oh, wow.
And it was, so we went in thinking that we may get 20, 30K, which was usually what UN told us, this is how it works. And then by the end of it, they were so blown away that they were just ready to move ahead. So that was a big point in the journey of Deepcell, both in terms of the financial means that helped us then build a prototype, but also a validation, really, of like people who have probably heard some of the most interesting pitches during that period. So that's how the project got kicked off. We were working after hours. We also had a software engineer who had a full-time job and was joining us after hours as well. And then we got data and more funding, and then we spun the company out in November of 2017. So Excellent. It's been 6 years now.
Excellent. So you've been at it about 7 years now.
6 years out, and then about a year and a half, 2 years before that in the university.
How did it start, and how did the idea change, if anything? Usually you start with something and you pivot, you modify it. How did it start, and where did it end now? I mean, it hasn't ended. You have a journey ahead of you. How did it change over the 7 years?
It changed a lot. I will give it to you to explain that. But one of the things that I tell myself is, if I ever become an investor, that's what I would focus on. If I become an early stage investor, I will help my founders work through the pivot that I know they will have.
Okay, so Mahyar, what was the pivot?
So the way it changed, so initially we were like, okay, so sales, interesting sales look different, right? And we were like, okay, so but what's the application, right? So we were basically intending to build an application for that. And the application initially that we actually got inspired by was there was this interesting group of cells called fetal nucleated red blood cells, which were circulating in mother's blood when they're expecting a baby. And the interesting thing is that there is no method to get these cells out. If there was a method, you could have basically take a test of mother's blood, and sort of it would be equivalent of basically taking a biopsy from the baby, right? So, and we were like, okay, so they look different.
You could separate it from mother's blood, essentially.
Right.
It's other things in mother's blood plus these foreign objects, foreign cells that you could get, and thereby do your biopsy. Yes.
Right. So we were like, okay, so this is a very clear application, clear need. Let's build that. And then we started developing that, and as part of it, well, we had to develop a lot of just the underlying tech, right?
When you say we, at this point, were you focusing on the idea, both of you together? I want to know who was who was selling the idea to who? Was it mostly she selling it?
So we both got, well, got interested by the tech. We were like, okay, so this tech is super cool. We have to just build it, right? And then we were like, okay, so what would be the application? And the application we actually got inspired by some of the conversation that we had with the industry folks. And we're like, well, this is clearly a problem in the industry, right? And then as we were building just the tech to do this, we realized that there's an overwhelming interest in many other applications that this tech could do at the same time. So, and then it just, it took us actually a couple of years to bring us to the mindset, to that pivot mindset that, well, actually, it's best for us to build the tech and enable, instead of just one application, enable now like
many of them. Make it generalized.
Tens, hundreds of applications.
Maybe this is a good time to talk about the tech. What is the tech? My understanding is the tech is the analysis of a single cell based on a multi-dimensional AI analysis of the cell's vision, essentially, the morphology or the shape of it, many factors.
So that's one part.
That's one part.
And then the other part is to make this analysis literally actionable, meaning that it's not just a model that analyzes a cell, it's a robot that picks the cells based on what the, well, when I say robot, it's not a humanoid robot.
Yeah.
It's a micro robot that sort of
pushes them aside.
Pushes the cells into different directions based on what they are, right? So, and so if you think about it, so it's all that hardware, it's the AI that powers that, and it's the data that kind of powers not just a single application, but basically a foundation model that powers a lot of application.
Okay, so that's the tech. The tech allows you to do some fundamental sorting of the cells that you have no information a priori about. But you don't judge what these cells are, right? You just separate them. You just put them into the different categories.
So the foundation model is trying to tease apart what looks similar or different from what, right? Now, there's a whole back end of database that we've built with a lot of context around a lot of these images. So we have built a database of over 2 billion images that we have context around. And that can help us serve our customers by showing them your cells look like diseased monocytes in the blood, or your cells look like late-stage cancer cells of skin, for instance. So we can provide that type of context, but we're not providing a clinical test. We're providing that information to our customers, to our users, some of whom are developing clinical tests, for example, for certain use cases. So that's one piece of it. Another part of the whole gamut of what we do at Deepcell is that we have built this database, and our biggest asset, one of our biggest assets, is this growing database where our customers, by just running the system, are providing a lot of information and context back to the community and to other users. So by providing links to saying these cells actually are similar to those cells, or I categorize them the same way, they're giving our AI more information. That's very hard to get to with the current way that
Not only
that
they
biology
give
works.
you the labels, they tell you what happened to them, right?
Yes,
The
they can.
eventuality of it,
Yep.
because that feedback is very important. Otherwise, you don't diagnose things.
Yeah, we don't.
You just
but
provide the platform.
There are specific problems in our field. For example, within diagnostics, there's a big category of what they call atypical cells, which are cells that a pathologist or a cytologist cannot categorize as a normal cell or a cancer cell. So they just call it atypical, and they pass it around to do other tests. What we can do is we can distinguish these cells from other types of cells. You can sort them in real time on the system, and we sort live cells because we're just watching and observing cells. We don't do anything harmful to them. So you can then, in a downstream, do whatever you want to do to figure out whether these are malignant cells or normal cells, and you can feed that information back. So that's the feedback loop that is very unique, and then it enables additional clinical tests that never existed before.
I'm sure you will have some challenges ahead, but you're already recouping some awards. You you just received the Life Science Catalyst Award by Biocom California, the association representing the California life science industry, and Deepcell REM1 platform. REM-I, thank you. I was about to ask you that. I forgot to ask you. REM-I. Why is it called REM-I? What's the abbreviation?
We just like the ring. It rings well. Well, because there's also the rapid eye
I'm sure
movement.
there's a reason there's an eye there. Come on, tell me.
So the rapid eye movement
Yes,
stage of
yes,
the
yes.
sleep.
You just wanted to separate that from that.
So we were like, okay, so this is a dreamlike experience, and it's when interesting things happen and cells are rapidly moving. So we were just inspired by rapid eye.
So there is no REM separate from rapid eye movement.
No.
But it's yours. Okay, it's eyes. All right. REM eye, everybody. And Deepcell REM eye platform named Cell Imaging Product of the Year by the organization Biotech Breakthrough. Round of applause for that. So the topic that I have discerned is disruptive AI-driven approach to single-cell morphology analysis to fuel deep biological discoveries. Hopefully the reward is deep biological discoveries that in a few years we will witness. But disruptive, why is it disruptive?
Well, it's very unorthodox to anything that people are doing out there because, yes, in one world, they come up with chemicals, they add it to the cells, and the cells react to chemicals, right? And then from that reaction, they sort of understand, okay, so what type of cell they're looking at. And it's almost like the Schrodinger's cat, right? As soon as you open the box, it's not the cell anymore. It's something else. It's the reaction of the cell to that chemical, right? Yes. So there is that world. And then there is the world of people who are just like spending hours behind the microscope, sort of analyzing, in some cases debating what they're seeing. So what we are doing is neither of that. We're actually like doing very scalable computational analysis using AI, but also keeping the cells alive to do interesting things post. And that's why it's disruptive to all like those disciplines.
None of your competitors do this.
So when we started, this was a wacky idea, and we were like why this is gonna work. Like now we actually when we launched a few months ago, we at this conference they were like, oh, so you guys are leading this trend of like, well, I don't know, yes, well, you could call it trend. So there are actually a few both small startups as well as big companies who are some of them basically they made their entire business selling chemicals. Now they're advertising biomarker free products, which is that basically that trend that people are referring to.
Excellent. You told us that your first check was $250K. Eventually, you have gotten something close to $100 million so far.
No, we finished the product with that $250K.
You finished the product with it? No, but I'm talking about the state that how much money have you raised so far, and how many people are you?
About 100 million, and we're a little over 100 people.
Very good. And this is a success story of a startup that has the path wide open for them. Deepcell REM eye platform has the potential to drive breakthroughs in understanding cellular processes, diseases, and therapeutic interventions. Which one of these do you think is going to be more important in the future, if you were to pick one?
I mean, it's very hard to tell. I think right now we have partners and users and customers who are actively pursuing all three: discoveries, developing new therapies, and developing new diagnostic tests.
Who's your biggest partner in this?
I don't think we have rights to share.
You can't tell.
Names,
okay. I'm not surprised.
Yeah, but what I would add to that is what we learn over and over is that you can outsmart your customer, meaning that you cannot tell them, hey, this is how you should use the product. You should basically build a product and see how they use it, and sort of based on that, change quickly and learn how to. So for that reason, we're trying to kind of offer a true platform that people could do many things with, and observe what they do to basically take that platform to the next step.
You also have some proprietary technologies, I think, to take the images, right? Is that something that you developed yourself?
Yes,
we
developed the hardware, yes.
Yeah. One other thing that we usually ask people, and I neglected to ask, and since you were both Sharifis, I think you would be proud to mention is, what are your concours ratings?
Oh, no.
26.
26, not too shabby. And yours?
Mine is large. 150 something.
Still is very good.
I was one of the last people who got accepted to the computer engineering program.
Well,
at
120 people they take.
Yeah,
and
I don't know, like it.
Okay, but there remain some challenges, right, in your path to stardom and doing all these wonderful things. And I've written some of these, and I would like to get your feedback on these. We probably don't get to all of them. One of them is the algorithmic challenge. Developing and refining sophisticated AI algorithms for high-dimensional cell morphology analysis can be challenging because ensuring the algorithms are accurate, robust, and adaptable to various biological contexts is a complex task. How does Deepcell address potential challenges in the accuracy and robustness of the algorithms, especially in the context of analyzing complex and heterogeneous biological data with the REM-I platform? And we already see ChatGPT hallucinates sometimes and tell us wrong. How can we be so sure that the results we can depend on?
Yeah, maybe I'll start and then you chime in. So I think about this in like a few different ways. One is that when you look at AI in life sciences, a lot of AI applications in life sciences, they relies on data sets that are large. That's what you need to start with to even be able to benefit from the value that AI and deep learning provides. A lot of that data is in the genomic space right now. So the community has decided over the past decade that they want to invest heavily in genomic analysis. The Human Genome Project was kicked off. And the challenge with applying AI to something that is hard to interpret is very real in life sciences. So you don't see the outcomes readily. It's not like you're talking to a chatbot and you can see what the answer is. It's very difficult to interpret the results, and therefore it's very hard for the life sciences community to adopt something like AI, where there's all sorts of biases. The beauty of the image data is that it's right in front of your eyes. So you can assess for yourself, you can see for yourself basically whether the result of the foundation model projections make sense or not. We provide very easy to use platforms that you can just visualize cells that the classifier, the model has categorized in different regions. So that is the first level of understanding of, does this make sense? Can I trust this? The other thing is that we have the sorting capability. Like we said, we don't have a diagnostic test to sell, but what we provide is the ability of the AI to tease apart healthy versus diseased, responding versus non-responding, patient cells that are reacting to cues versus not reacting. And then a clinical test developer can go and pull out those cells and do the ultimate clinical assessment based off of the cells that the AI is sending out. The point being that the AI is not the ultimate diagnostic test that a lot of people in life sciences are scared of. It's a means to give you purer samples and better understanding of what's going on in your sample. And then lastly, what I want to mention is we have been very diligent in how we have built the model. We have gathered a lot of information both from our employees and also amazing advisors that have guided us as to how to build this model to adjust for biases and make sure that we are collecting different portions of the universe appropriately as it relates to human samples, basically.
I mean, not much. Maybe from a different perspective, because I'm a trained computer scientist, kind of turned into, I don't know who I am now, but so as a computer scientist, you deal with very clean world, right? I mean, if you just open your coding IDE, everything is just clean and it's just your mind is very used to abstract and clean world. And then biology is the opposite end of that, right? There's just a number of confounding factors that could mess your models is just staggering. So I think one of the things that we did to overcome that, especially in early days, was to control that environment through innovation in hardware, because we weren't just like writing algorithms on existing data sets. We were generating the data sets ourselves. And that helped us, get a lot more efficient with algorithm development.
When you say hardware, do you mean the imaging hardware or the pushing hardware?
Both
of them.
right?
So those are proprietary. You have patents on those.
Yeah.
Okay. That leads me to the other point, interdisciplinary impact. You're bridging the gap between biology and AI, essentially, right? And it requires deep understanding of both these fields in order to succeed. Integrating diverse components in the REM-I platform, such as imaging, sorting, and analysis, poses a challenge in terms of seamless collaboration between experts from different domains. Okay, and the goal of course is to make an impact on various fields such as cancer biology, developmental biology, stem cell biology, gene therapy, and functional screening. None of them are small. I mean, these are huge areas. How does your company plan to ensure that the platform remains versatile and effective across all these diverse research disciplines? The requirements are very different.
I frankly think, well, first, it's not a problem that we have honed. Like we just say, like, oh, that's a solved problem. It's a challenge we deal every day, because people from those fields speak different languages. They have different ways to implement a project. The PDP process, the product development process, is very different across hardware, software. But like, there's a lot of differences, and I truly believe that the next generation of companies, the ones who are going to succeed in this multidisciplinary mode, are the ones that could nail like how these different groups of people, different paradigms could work together. And it's I don't know, I don't have a good answer. I mean, we think about it every day, but I think that's the first step, to just like accept that, hey, like we have to talk.
It's
and
a
we've
great
failed
challenge,
many
yeah.
times. We
Go
have
ahead.
failed many times. Like we have, like Mehiyar said, this is an active conversation internally. It's very difficult to bring in people who are used to the mindset of like agile, software development with hardware that it's ridiculous to think about a problem in the hardware world like that, and then the data issue, and then the bio part of things. So all these different people have very different life experiences, very different expectations of what a product means, what expectation of a customer could be. Even within our product managers, the people who are handling software and cloud versus hardware, it's very challenging to help them talk to each other. So we've gone through various ways of inventing on our own PDP process, which doesn't fit into either, and it's still a work in progress. I can't tell that we have found a solution, but that's something that's very real and gets very real as things become slower and harder to just have very effective communications as the company grows. So it's challenging. The last thing that you mentioned there was like all these application areas and being very diligent about where this data set and this model is going. Because if you get a biased set of customers that push your sample sets and data set towards one area and not recognize that, now...
The generality that you need
exactly.
to keep. Yes.
Then, because when we first got started, we had a lot of thought going into how do we want to build this data set. Now, if we open it up completely and let everybody bring in their data, then we got to adjust for potential biases that can introduce. And having a lot of experts around the table, our key opinion leaders, our scientific advisory board, that are also very multidisciplinary and all have interests and understanding of all these different applications, has helped a lot in figuring out how we should move forward and correct for data biases.
Related to that, but slightly different, is biological validation and the real-world applications. This is similar to self-driving car. In essence, you can write a code that predicts all these corner cases, but in reality, it rains and it snows and somebody walks in front of it, all bets are off, because the real world is different from the AI imagined world. How does your company plan to validate the biological advances and the accuracy of finding from that comes from REM-I platform? Additionally, what strategies are you putting in place to translate these discoveries into clinically relevant applications in real-world scenarios.
Yeah, so that's not our job. That's our customer's job.
Or you provide the platform and they do it. Okay.
But what we are here to do is to make sure that the foundation model is always producing the same exact insights every time you run it. And there's this biological processes that you have negative controls, positive controls, the number of controls that you have technical replicates, biological replicates. So we put the foundation model on REMI through a lot of these well-known tests in life sciences across many different samples.
Excuse me, people in the back, I see Mr. Fatih back there. If you please take your conversation outside because it's really distracting. Thank you very much. Go ahead.
So we have put the platform through a lot of well-known biological replicates, technical replicates tests to make sure that the model is not hallucinating, is always creating the same maps, the same patterns from the same exact samples. But in terms of developing a clinical tests, we're glad that we are enabling our customers to do that.
I have many more questions, but I don't think we have time for all of them. And I would like to leave some time for your questions, and I'm sure you will have some questions. Mehran already raised his hand. I will ask one more question, and hopefully you can get to it quickly. Ethical considerations. The use of AI in analyzing biological data raises ethical considerations, particularly regarding data privacy and consent. Ensuring compliance with ethical standards and regulations can be complex, especially when dealing with sensitive health data. What steps in Deepcell you're taking to address these ethical considerations, particularly concerning data privacy and consent?
I mean, we definitely
you have good lawyers.
Well, I mean, we offer the customers with very clear terms. But there's one thing fundamentally: if your unit of data processing is an individual, is a patient, then the concerns around privacy is at a much higher stake than when the unit of your process is a cell. So. And for us, it's the latter, right? So, like, even if I have, the full sample of a patient, just by looking at the cells, I cannot tell, like, which patient it is coming from. And so for us, I guess we're privileged to be in a simpler use case that the privacy is not, the first thing that we have to tackle. But obviously, we take it seriously.
Okay. We have 5 minutes, and I would like to start with a question. I have some more questions if there are no more questions. Mehran wants to ask the first question, right? And we need a mic. Do we have a mic? Can we use, why don't you use Mahyar's? Go ahead, Mahyar, until we get the other mic.
Thank you. My name is Mehran, and congratulations on your success. It's very impressive what you've accomplished, and maybe one day you'll also teach a side course on how you make a company like yours and marriage work at the same time so well. So that's a whole other subject. But my question is this: I want the scope of the question. The basis of the question is regarding the scope of the cells that you now analyze, and you started by talking about a specific type of cell within a pregnant woman's body that you identified, and that leads to certain implications. In my field, which is human longevity. One of the 12 hallmarks of aging as of last January, and it's expanding now, is called senescent cells, or some people call them zombie cells. And these are cells, as I'm sure you know very well, stop dividing, and through that process, then they secrete certain chemicals and other components that lead to inflammation and eventually disease. And the scope of my question is are you at a point where even that type of a scenario you can identify, you can address, you can use AI to kind of come up with implications of that?
The short answer is yes. A little bit longer answer is that we have a few users who have specifically evaluated REMI on longevity applications, both looking at senescent cells and also looking at therapies. So we're seeing one particular company, which again, we can't reveal their name, that at least by looking at the cells, it looks like their drug is working. So there's hope for the future. We want to actually get access to that drug now, seeing the results. But the beauty of AI is that, of course, in a lot of cases, we are super excited by being able to scale up what a physician, a clinician, a researcher is doing right now manually. But in a lot of other cases, we're seeing that AI is revealing information that's very hard to see by eye. I don't know how many shades of gray a human eye can detect, but the grayscale pixel is 0 to 256. I don't think that's the scale that even the human eye can detect. So we're really excited by it.
We have another question from Castro. Castro, please introduce yourself and tell us where you work.
Hi. Congrats on your success. My name is Castro, and I work at Google. We could be colleagues, but no. So actually, I got my PhD in machine learning and healthcare. I work with Johns Hopkins and UCSF hospital. My question is very short. Explainable AI. Do you explain the AI to your customers? Like, is it a automated process that basically boosts up the trust? Because when I say to a doctor that this is a disease and my machine learning says that this guy or this woman has cancer, they say, okay, why? We don't accept that. So what is the logistic for that?
Yeah, I mean, great question. One of the things that we see over and over is that our customers, they cannot just take AI as like, okay, well, it works, right? They need to know why, how. They actually want to publish papers, with our instruments. So they have to explain it to their own audience. So for us, the interpretability problem is a very important one, and we have done several things to bring interpretability to what we do. One is, in addition to what the black magic called deep learning does, we also just measure everything that the human eye can see and explain. So meaning like, what is the cell diameter? What is the elongation ratio? Well, everything that you could put in like a word on it, we measure and we explain, right? So that's one part. The other part is that, you mentioned hallucination. So hallucination is not necessarily a bad thing, right? If you actually can use your AI to hallucinate about what would have happened if you take your point in the latent space and moved it around. Like, how would that cell would have changed? Like, that would basically explain what your embedding space or the latent space look like. And we do things like that. Of course, it's just starting point because it seeds a hypothesis in your user's mind, and then the user could go and investigate that. So the short answer is it's very important for our users, and we are looking at many ways to add interpretability. We welcome people who have thought about these questions. So come and talk to us.
And our last question comes from the lady over there who would introduce herself. And
my name is Mahbub Davar, and I have two short questions. First of all, I noticed
just one, please.
No, it's very short. Both of you are co-founder. Who is the founder? Maybe I missed it at the beginning. Yes?
They did it together, yeah.
So the founder is both of you?
Three of
Yes.
We have three co-founders.
Three co-founders.
Oh, three co-founders. So there is no founder, three co-founders. Okay. My other question is, I assume that is not a non-profit organization, so are you willing to sell your company to a big company?
It is for profit.
It's for profit.
For profit.
Yeah,
So,
they raise
so you
money,
can
they
sell
want to make a lot of money.
Yeah. Are you willing to do that?
To do what?
How
to
much?
sell it.
Let's make a deal. We get 10% over here.
I'm not the buyer, but I am thinking about it. So thinking about someone else.
Any serious offers would be negotiated over there. Thank you very much. Thanks a lot. Thank you for your time. Thank you for your presence over here on behalf of the community, Iranian community, Persian Tech Network, and Plug and Play. We thank you for the time and the attention you paid over here.
Thank you for having us.
Thanks a lot. Thank you.